Okay, welcome back, everybody. I'm Clayton Krager. I'm the Watershed Stewardship Coordinator for the North Coast region, and I'll be your moderator for the rest of the afternoon here. Our shift is going to focus a little bit to the Upper Basin, and I was just chatting with Vradenburg of the Klamath Watershed Partnership, who is our next speaker, and we'll be talking about some exciting sort of restoration and adaptive management being conducted on at a lakeside farm on the edge of Upper Klamath Lake, just from the early days of K-Bump, where we had very few restoration projects. And it seems like the focus is shifting to rapidly maturing sort of restoration activities. And Leanne, we're excited to hear from the Upper Basin. So take it away. Thank you.
Great, thank you, Clayton.
We can see your slides.
Okay, thank you. Yes, I'm Leigh Vradenburg, and I'm project manager with the Klamath Watershed Partnership. We are the Watershed Council for the Upper Klamath Basin. Today, I want to talk about a holistic approach to wetland restoration that can have multiple benefits to stakeholders across a spectrum of interests, using Lakeside Farms on Upper Klamath Lake as the case example. So my title is different than shown in the agenda, because although sucker rearing is certainly a warm and fuzzy element of this project, it's not the compelling message that I hope will come out of this project.
Leanne, sorry to interrupt. Can you go to presentation mode? Thank you.
To provide some context for where the project came from and the initial driver to do it, for some time, there's been an interest and concern over water, or more specifically, the quality of the water that's pumped from agricultural operations into water bodies. Many of these properties are flooded over the winter for multiple reasons, including control of crop pests in the soils, provision of waterfowl habitat, and pre-irrigation. And then as this water's pumped off in the late winter or early spring to ready the fields for planting, nutrients and sediments may contribute loading to waters of the state. In this particular case, it was operations around Upper Klamath Lake that came under scrutiny over 4 years ago, and the perceived, or in some cases quantified, phosphorus loading associated with this pumping. The Oregon Department of Agriculture hosted a meeting with producers around the lake to discuss these concerns and to begin a discussion of solutions. And then they invited project partners in to help brainstorm. Lakeside Farms was at the top of the list of these properties. This property is also referred to as Cove Point in some of the literature. It's on the southeast side of Upper Klamath Lake, right along Highway 97 and south of the U.S. Fish and Wildlife Service Hanks Marsh property. It's a 422-acre farm that's been in production since the 1940s, when it was diked and separated from the lake. As with its marshy neighbor to the north, this area was historically a wetland, and now its peat soils have subsided and it sits several feet below lake water level. There are springs on the southeast side of the property that run year-round, previously as much as 2,000 gallons a minute, but flows have substantially decreased in recent years. And in the early 2000s, a wetland was developed on the east side of the property with the intent of treating water, but it didn't function as designed and was converted back to farmed acres. So based on these discussions, ODA conducted more intensive sampling starting in 2019. And total phosphorus concentrations at the primary pump outlet on Lakeside Farms ranged from 0.07 to 0.44 milligrams per liter. The TMDL for the lake calls for target concentrations for inflows to the lake to be around 0.11 milligrams per liter to achieve the desired 40% reduction in loading. For the pumping situations, this was approached as 0.11 above background, which at this site was variable based on samples from the springs, which were around 0.05 milligrams per liter. The pumps were outfitted with flow meters, but since the pumps only run intermittently and nutrient concentrations were variable, it was difficult to determine the load of phosphorus coming off the property. Regardless, the goal was concentration. So the approach became, do we simply solve that problem, or is there a bigger opportunity to address the issues at hand? To get to the issue, we have to acknowledge what these areas once were, which were wetlands. To go back to Randy's opening this morning, we're at a tipping point in the Klamath caused by anthropogenic actions and exacerbated by climate change. We've lost more than 95% of historical perennial aquatic habitats in what was a wetland-driven system. We've got to do whatever we can to restore and maintain the function of these wetland systems if we want to have any hope for everything that results from them, including water quality, water quantity, and dependent species. Based on this understanding, the issue here became balancing the water and nutrient budgets to maintain the existence and function of the wetlands and the wetland functioning systems. To acknowledge the process that ensued, KWP got a grant, a technical assistance grant from the Oregon Watershed Enhancement Board for planning and topographical infrastructure and soil surveys on the property. We also had an opportunity early on to pursue U.S. Fish and Wildlife Service funding, also called Merkley funding, for implementation. We then went through a structured decision-making process. We developed a problem statement, values, objectives, a range of restoration options, scoring criteria, triggers, risks, constraints, etc. We discussed ancillary project opportunities with other partners and then began planning implementation. As we began implementation, we were and are still constantly evaluating opportunities for enhancement to better meet our objectives or to meet new ones. And then we evaluated how best to monitor our success in meeting the range of objectives, some of which will be quantitative and some qualitative. I want to acknowledge two key individuals in the project. Dustin Taylor is a private lands biologist for the Partners for Fish and Wildlife program based out of the Klamath Basin refuges. We're fortunate that he came into this project early on as he was the lead in the design and implementation. And then Carl Winter is a co-owner of Lakeside Farms LLC, and he was the primary liaison with the other owners for this project. I can't emphasize enough how critical landowner engagement is. And Carl was especially beneficial to this whole process because he believes there should be a bigger vision for restoration in the basin, and he wanted this project to be an example. He was willing to take a risk to be able to do something more meaningful. So the on-the-ground result of all of this planning to address the issue had a couple of main activities. The farm land was leveled to reduce the volume of water needed to flood it. Less water picking up phosphorus from the soils means less water to be managed later. Then a 70-acre wetland was constructed to take water drained from the fields as well as spring water. This wetland allows management of the timing, amount, and ideally quality of the water to be pumped to the lake if it's pumped at all. This approach maintains a seasonal wetland function and benefits of winter flooded agricultural fields, and it restores semi-permanent wetland function and benefits through the new 70-acre wetland. When we talk about wetland loss, it's these types of semi-permanent wetland areas that are completely disappearing from the landscape. From this approach, we've gained associated benefits and opportunities. The leveling and upgrades reduced maintenance for farm operations, and the remaining farmable acreage still allows for a financially viable operation. The seasonal and semi-permanent wetlands promote a range of habitats for birds and other wetland-dependent species. As noted, These habitats are being lost at an exponential rate. In this particular case, the landowners place a high value on wetlands for waterfowl habitat and hunting. And there are, and hopefully will continue to be, incentives for these practices. The existing ponds on the property, improved by provide opportunities for sucker rearing and evaluation of habitats and survival. Monitoring, especially for water quality, will allow for adaptive management and evaluation of the project. And the list goes on. To highlight a few of these opportunities with a few more details, sucker stocking was coordinated with Christy Nichols and the U.S. Fish and Wildlife Service Fish and Aquatic Conservation Program and the rearing program through Gone Fishing. The objective was to stock 200 millimeter Lost River and short-nosed suckers to grow to more than 300 millimeters for restocking to the lake and to serve as a redundant population. For the ones transferred to the lake, it is hoped that this larger size will improve their chances of survival. So far this year, 3,840 suckers have been stocked. Of those suckers, 999 have been stocked with and outfitted with pit tags. A detection array will allow the U.S. Fish and Wildlife Service to monitor their numbers as well as their use of different habitat types in the pond. And so far in the 13 days, 116 fish have been detected by the arrays. We're also working with River Design Group to design a flow-through channel between the two spring-fed ponds on the property. The goal would be for the channel to have faster water habitats that could support spawning and slow water areas that could support juvenile rearing and adult resting during spawning activity. This is still in the design phase and hasn't been funded yet. KWP and Partners for Fish and Wildlife currently have a project to address declining populations of native wokas around the lake. And this spring, they transplanted around 70 plants from Agency Ranch at the upper end of the lake to the sucker pond at Lakeside Farms. They'll monitor the success of these plants and possibly transplant more in the future. KWP is working with Megan Skinner from the Fish and Wildlife Service under a grant from the National Fish and Wildlife Foundation to monitor water quality at multiple sites on the property. This monitoring will help inform actions such as the potential quality of water should the pumps be turned on, and over time, the effectiveness of the wetland for sequestering nutrients. The latter may be used to help guide projects on other properties. We just started sampling in May, so results from that will come later. Other things that have come out of this project include the identification and treatment of yellow flag iris. Although abundant below the lake, spread of this population of invasive iris within the lake, especially the Hanks Marsh, would reduce habitat quality and is a high priority for treatment. We're also talking with the Klamath tribes about additional sucker stocking in the drainage ditch on the east side of the farm. And we are keeping discussions and options open to partner with neighboring landowners for bigger projects in the future. The message of Lakeside Farms is of hope when we fully invest into the underlying issues. We could have simply solved the problem by mechanizing, converting to sprinkler irrigation for perceived irrigation efficiencies. We could have stopped phosphorus loading to the lake, but at what cost? Reduced flexibility in the farm, no waterfowl habitat, reduced engagement of the landowner in big picture solutions, and maybe most importantly, loss of ecosystem functionality by loss of the wetlands. By understanding the problem, but addressing the underlying issues, we've developed a pathway for restoration that touches on multiple stakeholder interests. By managing water and consequently nutrients, we continue to provide for sustainable agriculture and with it, farm revenue for the landowners and on-site water management that can benefit the project. With the wetland, we're benefiting waterfowl and other wetland-dependent species, and we are meeting a key landowner objective. By addressing water quality, we will keep the farm in compliance with regulators, and monitoring will feed into management and solutions basin-wide. And for suckers, we're providing rearing, redundancy, hopefully spawning, and a greater understanding of their ecology. Are we alone going to solve the problems of the lake, or the future of farming, or save the suckers, or the waterfowl of the Pacific Flyway? Probably not. But if we could replicate this 30 times across the basin, it would start to make a difference. Such projects with an ecological basis that touch on socio-political issues as well, at a very small scale, may just create a blueprint for ecosystem recovery in highly modified systems. I'd like to thank everyone that has contributed to this project over the last few years, and I'll take any questions.
Thank you, Leanne. I actually submitted one question to the chat because I couldn't figure out how to use the QA procedure, but basically, do the treatment wetlands employ any kind of enhanced treatment like phoslock or post-treatment like biochar filtration? If not, is there any plans to do so?
At this point, they don't, because we are, this is just, as we said, in an adaptive management approach. We would like to use the design as is and the monitoring to see where we're heading. And, you know, as this wetland matures and develops, you know, we need to give it a window of time to function. I mean, if you look out there now, though, it's amazing. I mean, the tules are coming up. It's establishing, even though it's, you know, this is its first full season. So, you know, we haven't, you know, that's part of the options that are on the table, potentially with the neighbors in the future, should they be needed. But right now, they're not a part of the plan.
Yeah, I think we saw that with Andy Hamilton's Wood River wetland water quality monitoring project, that it takes some time for the wetland soils to reactivate or reaccrete, and for their function as a phosphorus retention to increase over time. Okay, thank you. I don't see any other questions in the chat, either the chat or the Q&A. Thank you for being here today and giving us an update on this. I hope we have some results back again sometime.
Leanne, it looks like there is one more question from Maya Singer. I can just read it if you want. Leanne, can you speak a little bit about the treatment wetland design? Was it undertaken in terms of vegetation area, flow path, residence time, etc., and what nutrient removal is expected?
Yeah, so I can answer some of that, Maya. Thank you for the question. Yeah, so the design of the wetland is primarily based on anticipated volumes, including water coming off of the farm fields, as well as the spring volume, which admittedly is variable. So there are unknowns, and in fact, even just in the period of planning for this wetland, we saw kind of unprecedented flow variation in the spring, potentially resulting in a lot less flow than it was designed to handle. So it's primarily based on residence time, being able to take some flow from the springs, all of the water pumped on, or removed from the ag acres, to hold that. And that could be in a very, very wet year, could be potentially pumped to the lake because that infrastructure is still there. But the idea would be to basically hold that at least for some period of time to allow for uptake of the nutrients. And yeah, so it's in variable depths. There are deeper areas kind of in that map that I showed. There's kind of a channel, if you will, from south to north, and areas in excess of 3 feet, and then more shallow areas, mounded areas to provide for that macro topography, micro topography throughout the wetland to get some submergent vegetation, then emergent vegetation to kind of mimic those natural systems. And as far as the nutrient removal that's expected, we don't know at this point. I think, you know, the idea being to use holding the water as the primary mechanism rather than discharging it. But we will see, you know, what we get for nutrient removal over time.
Okay. Thank you. And thank you, Randy, for noting that. Okay. I don't see any other question. Oh, we got another one in there. Okay. This one is from Aline Ortega with Farmers Conservation Alliance. And her question is, have hotspot areas in Upper Klamath Lake been identified to guide work on areas where phosphorus removal would occur?
I guess yes and no. I think, you know, ODA has worked with some of these properties that are pumping water and getting an analysis of that, and those landowners are working with various partners for treatment. And I think there's more kind of diffuse areas as well. And I don't know that it's hotspots as much as non-point source, but yeah, there is data that kind of guides that. Some of it's referenced in some of the water quality assessments and watershed action plans for the basin.
So I saw Beth Pitzerak of ODA earlier. I don't know if she's still participating, but maybe Beth, if you could drop something. I know you guys had a water quality monitoring program, as did the Klamath tribe. And I know that that guided some of the results of the focused work that you're doing now. And then, of course, there's the Upper Klamath Watershed Action Plan, which Leanne and I are both members of that steering committee. And they are using sort of science-based prioritization to identify restoration and locations. So there are some efforts in that, generally in that regard. I don't know about specifically. But. All right. All right. That, Leanne, I thank you so much for your talk today.